The nutrient I was given is protein. Proteins are the large molecules that our bodies need to function properly. They consist of amino acids. The structure and function of our bodies depend on proteins, and the regulation of the body's cells, tissues, and organs cannot exist without them. Dietary protein is a vital source of amino acids. Proteins ingested in the body are digested into amino acids or small peptides that can be absorbed by the intestine and transported in the blood. Another source of amino acids is the degradation of defective or unneeded cellular proteins. Protein is so important because protein is in every cell in the body. Our bodies need protein from the foods we eat to build and maintain bones, muscles, and skin. We get proteins in our diet from meat, dairy products, nuts, and certain grains and beans. Proteins from meat and other animal products are complete proteins. As I said, protein is made up of amino acids. Amino acids are the building blocks of protein. There are around 20 different amino acids. These 20 amino acids can be arranged in millions of different ways to create millions of different proteins, and each protein has a specific function in the body. The structures differ according to the sequence in which the amino acids combine. Amino acids are organic molecules that are made of carbon, hydrogen, oxygen, nitrogen, and sometimes sulfur. It is the amino acids that synthesize proteins and other important compounds in the human body, such as creatine, peptide hormones, and some neurotransmitters. Proteins play a role in nearly every biological process, and their functions vary widely. The main function of proteins in the body are to build, strengthen, and repair or replace things such as tissue. They can be structural, like collagen. They can be hormonal, like insulin. They can be carriers, for example, hemoglobin, or they can be enzymes such as amylase. All of these are proteins. Some interesting facts about protein are as follows. The word protein is derived from the Greek word proteus, which means primary or in the lead. Like carbs and fats, proteins are considered a major nutrient in the body due to their energy they provide. Protein is essential for life, and after water, protein is the most plentiful substance in the body. Proteins grow, maintain, and replace tissue in our bodies. Therefore, our muscles, organs, and immune systems are mostly made of protein. There are over 20 slightly differing amino acids. Our body can produce around 13 of these, but there are 9 amino acids that our body cannot make itself. These are called essential amino acids, and we obtain these by eating certain protein-rich foods. Like other energy sources, carbs and fats, too much protein can lead to weight gain. One of the only disorders linked to protein would be protein deficiency. Protein deficiency is unusual as an isolated condition. If a person lacks protein, they normally have a wider lack of nutrients and energy due to low food intake. This may be due to poverty or illness. Very low protein intake can lead to weak muscle tone, edema or swelling, thin and brittle hair, skin lesions, and in children, stunted growth. Biochemical tests may show low serum albumin and hormone imbalances. Eating more protein may boost muscle strength and encourage a lean, fat-burning physique. This, of course, depends on total food intake and activity levels. Protein deficiency is rare in the United States unless it results from a disorder such as anorexia nervosa or later stages of cancer.
Small intestine. Small intestine is part of the intestine that runs between the stomach and the large intestine. The small intestine is part of the gastrointestinal tract between the stomach and the large intestine, and is where most of the absorption of food takes place. The small intestine has 3 distinct regions: the duodenum, jejunum, and ileum. The duodenum is the shortest part of the small intestine and is where preparation for absorption begins. It also receives bile and pancreatic juice through the pancreatic duct, controlled by the sphincter of Oddi. The primary function of the small intestine is the absorption of nutrients and minerals from food, using small finger-like protrusions called villi. The small intestine is where most chemical digestion takes place. Many of the digestive enzymes that act in the small intestine are secreted by the pancreas and liver and enter the small intestine via the pancreatic duct. Pancreatic enzymes and bile from the gallbladder enter the small intestine in response to the hormone which is produced in the small intestine in response to the presence of nutrients. Secretion, another hormone produced in the small intestine, causes additional effects on the pancreas, where it promotes the release of bicarbonate into the duodenum in order to neutralize the potentially harmful acid coming from the stomach. The three major classes of nutrients that undergo digestion are proteins, lipids, which are fats, and carbohydrates. Digested food is now able to pass into the blood vessels in the wall of the intestines through either diffusion or active transport. The small intestine is the site where most of the nutrients from ingested food are absorbed. The inner wall of the small intestine is lined with simple columnar epithelial tissue. Structurally, it is covered in wrinkles or folds called piculi circulars, which are considered permanent features in the wall of the organ. They are distinct from ruggage, which are considered non-permanent or temporary, allowing for distension and contraction. From the circulars project, microscopic figure-like pieces of tissue called villi. Then individual epithelial cells also have finger-like projections known as microvilli. The functions of the piliac circulars, the villi, or the microvilli are to increase the amount of surface area available for the absorption of nutrients and to limit the loss of said nutrients to intestinal functions. Some diseases are geriatritis, ascenitis, Salmonella enterica, Campylobacter, vulvus, hernia, and pancreas diffusion.
The liver and the gallbladder are my organ and also the small sac attached to the liver. The liver is a large, meaty organ that sits on the right side of the belly, weighing about 3 pounds. The liver is reddish-brown in color and feels rubbery to the touch. Normally, you can't feel the liver because it's protected by the rib cage. The liver has two large sections called the right and the left lobes. The gallbladder sits under the liver along with parts of the pancreas and intestines. The liver and these organs work together to digest, absorb, and process food. The liver's main job is to filter the blood coming from the digestive tract before passing into the rest of the body. The liver also detoxifies chemicals and metabolizes drugs. As it does so, the liver secretes bile that ends up back in the intestines. The liver also makes proteins important for blood clotting and other functions. With the help of vitamin K, the liver produces proteins that are important in blood clotting. It is also one of the organs that break down old or damaged blood cells. The liver plays a central role in all metabolic processes in the body. In fat metabolism, the liver cells break down fats and produce energy. Facts: it's the second biggest organ next to skin. The first liver transplant wasn't a very great success. The liver is the only organ that can completely regenerate, and all vertebrates have one. Liver conditions: hepatitis, cirrhosis, liver cancer, liver failure, ascites, gallstones, hemochromatosis, primary sclerosing cholangitis, primary biliary cirrhosis. The gallbladder is a small pouch that sits just under the liver. The gallbladder stores bile produced by the liver. After meals, the gallbladder is empty and flat, like a deflated balloon. Before a meal, the gallbladder may be full of bile and about the size of a small pear. In response to signals, the gallbladder squeezes stored bile into the small intestine through a series of tubes called ducts. Bile helps digest fats, but the gallbladder itself is not essential. Removing the gallbladder in an otherwise healthy individual typically causes no observable problems with health or digestion, yet there may be a small risk of diarrhea and fat malabsorption. The gallbladder's absorbent lining concentrates the stored bile. When food enters the small intestine, a hormone called cholecystokinin is released, signaling the gallbladder to contract and secrete bile into the small intestine through the common bile ducts. The bile helps the digestive process by breaking up fats. Gallbladder conditions: gallstones, cholecystitis, gallbladder cancer, gallstone, pancreatitis. Facts: your gallbladder serves as a storage pouch. Gallstones are formed mostly from hardened cholesterol. A low cholesterol and low fat diet is best for a healthy gallbladder. A diet for your heart is good for your gallbladder too. Rapid weight loss could cause gallstones. Close to 12% of the population has gallstones, but only a few cause problems.
My organ is the stomach. The stomach is a muscular organ located on the left side of the upper abdomen. The stomach receives food from the esophagus. As food reaches the end of the esophagus, it enters the stomach through a muscular valve called the lower esophageal sphincter. The stomach secretes acid and enzymes that digest food. Bridges of muscle tissue called rugae line the stomach. The stomach muscles contract periodically, churning food to enhance digestion. The pyloric sphincter is a muscular valve that opens to allow food to pass from the stomach to the small intestine. The stomach can be divided into 4 distinct parts. These are the cardia, fundus, corpus, and pylorus. The cardia is the first portion of the stomach and is where food content passes from the esophagus into the stomach. The acids and enzymes referred to as the gastric juices are manufactured in the cardia. The fundus stores undigested food and also the gases released from the chemical digestion of food. The body of the stomach, or the corpus, is the largest of the 4 parts that makes up the stomach, and this is where the bulk of the partial digestion occurs. The pylorus is connected to the duodenum, or the beginning of the small intestines. The contents of the stomach move into the small intestines via the pyloric canal. Here are some of the diseases and conditions that you can get in your stomach. The first one is gastritis. Gastritis occurs when the lining of the stomach becomes inflamed or swollen. There can be many possible causes for gastritis and can last from short time periods to many years. The next one is gastroenteritis. Gastroenteritis is an inflammation of the gastrointestinal tract in both the stomach and the small intestine. Children, the elderly, and people with compromised immune systems can get seriously ill. The next one is gastroparesis. Gastroparesis is an uncommon disorder where the stomach is unable to empty its contents, yet there are no apparent signs of blockage. The underlying problem is a disturbance of the hormonal and nervous control of the stomach emptying. The next one is non-ulcer dyspepsis. Non-ulcer dyspepsis is a common problem where patients suffer from indigestion and other symptoms suggestive of an ulcer, yet no abnormalities are found upon investigation. The next one is peptic ulcers. Peptic ulcers refer to a break in the surface lining of the stomach or duodenum, which is deep enough to produce a shallow crater. Rarely they can be found in the lower esophagus or beyond the duodenum in the small intestine. And the last one is stomach cancer. Stomach cancer, also known as gastric cancer, was at one point the second most common cancer in the world, but has since declined. Symptoms may include significant weight loss, GI tract bleeding, and difficulty swallowing. Some fun facts about the stomach are: an adult stomach can hold around 1.5 liters, nearly half a gallon of food and drink. Your stomach produces a new layer of mucus every 2 weeks. It does this because hydrochloric acid could digest your stomach and other organs, and the mucus protects the stomach from that happening. When you swallow your food, you swallow a small amount of air. When you drink soda or carbonated beverages, you also get lots of air in your stomach. The best and easiest way to get rid of all this air is to burp. Did you know when you blush, so when your face turns red, the lining of your stomach also turns red? That's all for my video presentation on the stomach.
What medical condition did I get? I got the hernia. How does one get a hernia? A hernia occurs when an organ pushes through an opening in the muscle or tissue that holds in place. For example, the intestine may break through a weakened area in the abdominal wall. Hernias are most common in the abdomen, but they can also appear elsewhere. Now here are some treatments for a hernia. Monitoring the condition if needed. The surgery can return tissue to its normal location and close the opening. There's also supportive care, which is monitoring for changes or improvement. And one of the supportive care and things you can do is massage the hernia. Another thing is internal repair devices. There are supportive devices and specialists that have devices that can help. Primary care provider and general and surgeon. Now some restrictions are heavy lifting, straining during bowel movement, becoming overweight, smoking to avoid coughing as it could strain the hernia, sex if it irritates the hernia, if it is painful. Now some interesting facts. There's more than one type of hernia. Hernias are more common in males. Simply lifting something heavy can cause one. The more severe the hernia, the more serious the complications can be. Surgery is the only way to repair a hernia, but you can massage it to make the symptoms feel better. Obesity plays a big role in the development and treatment of hernias. Now, as I stated earlier, there's more than one type of hernia. There's the epigastric, the umbilical, inguinal, and femoral hernia. The two most common ones are umbilical and femoral, but the epigastric also occurs with small children.
Carbohydrates by Brooklyn Sandifer. The scientific name for carbohydrates is carbohydrates. Carbohydrates are any type of large group of organic compounds occurring in food and living tissues and including sugars, starch, and cellulose. They contain hydrogen and oxygen in the same ratio as water and typically can be broken down to release energy in the animal body. Digestion and absorption occurs along the gastrointestinal tract, and remaining undigested carbohydrates are then eliminated from the colon. Amylase, an enzyme which breaks apart starches, is found in the mouth and in small intestine. Similarly, the three major enzymes which break apart sugars, sucrase, maltase, and lactase, are also found in the mouth and in the small intestine. Once these digested starches and sugars begin to move through the small intestine, they are able to be absorbed. Carbohydrates provide a significant amount of fuel to the human body. The basic structure of carbohydrates is a sugar molecule, and they are classified by how many sugar molecules they contain. The general atomic structure for a carbohydrate is CH2ON. Monosaccharide, which are simple sugars that serve as fuel molecules as well as fundamental constituents of living organisms, are the simplest carbohydrates and are required as energy sources. The two digestible carbohydrates are starches and sugars, and both of these carbohydrates are digested or broken down into their most elementary form along the gastrointestinal tract. Carbohydrate digestion begins in the mouth. The salivary glands in the mouth secrete saliva, which helps to moisten the food. The food is then chewed while the salivary glands also release the enzyme salivary amylase, which begins the process of breaking down the polysaccharides in the carbohydrate food. There are many interesting facts about carbohydrates. 1. Most of the time, the hydrogen to oxygen atom ratio of a carbohydrate is 2 hydrogen atoms for every 1 oxygen atom. This is the same ratio as in water, H2O. Second, the word saccharide comes from the Greek origin, saccharon, which means sugar. 3. Carbohydrates make up between 2 and 3% of the average person's body mass. 4. Some carbs help our bodies to absorb calcium. 5. Many people try to use a low-carb diet to lose weight, but we all need some carbohydrates to survive. 6. Carbohydrates help to ensure that our cells get the energy they need to perform well. There are many diseases that come with carbohydrates, one being cancer, another being cardiovascular disease, another being obesity, and non-insulin dependent diabetes mellitus.
I have iron. Iron is an essential mineral. Iron is necessary for the transport of oxygen and for oxidation by cells. Deficiency of iron is a common cause of anemia. Food sources of iron include meat, poultry, eggs, vegetables, and cereals. According to the National Academy of Sciences, the recommended dietary allowances of iron for women aged 19 to 50 is 18 milligrams per day, and for men 19 and above, 8 milligrams per day. Iron overload can damage the heart, liver, gonads, and other organs. Iron overload is a particular risk in people who may have certain genetic conditions, sometimes without knowing it, and also in people receiving recurrent blood transfusions. Iron absorption occurs predominantly in the duodenum and the upper jejunum. The mechanism of iron transport from the gut into the bloodstream remains a mystery despite intensive investigation and a few tantalizing hits. A feedback mechanism exists that enhances iron absorption in people who are iron deficient. In contrast, people with iron overload dampen iron absorption. The physical state of iron entering the duodenum greatly increases its absorption, however. Heme iron is found in animal foods that contain hemoglobin, such as meat, fish, and poultry. Heme iron is the best form of iron, as up to 40% of it is readily absorbed by your body. Good food sources of heme iron include beef, pork, chicken, veal, fish such as halibut, haddock, perch, salmon, or tuna, and shellfish such as clams, oysters, and mussels. Sources of non-heme iron. Non-heme iron primarily comes from plant sources and is present in grains and vegetables. This is the form added to foods enriched or fortified with iron, as well as many supplements. It's estimated that 85 to 90% of total iron intake comes from the non-heme form, while 10 to 15% comes from the heme form. In terms of its bioavailability, non-heme iron is absorbed much less efficiently than heme iron. Good sources of non-heme iron include fortified cereals, rice, wheat, and oats, dark green leafy vegetables like spinach and kale, dried fruits like raisins and apricots, beans like lentils and soybeans. Iron deficiency anemia is a common type of anemia, a condition in which blood lacks adequate healthy red blood cells. Red blood cells carry oxygen to the body's tissue. Some symptoms of this are extreme fatigue, weakness, pale skin, chest pain, headache, or cold hands and feet. Some causes of anemia can be blood loss, a lack of iron in your diet, an inability to reabsorb iron, and pregnancy. Some fun facts about iron. Iron's atomic number is 26. Its atomic symbol is Fe. Its atomic weight is 55.845 atoms. The density is 7.8 grams per cubic centimeter. The phase at room temperature is solid. And the most common type of isotopes are iron 56.
I'm Isaac, and my digestion video in anatomy class is about calcium. a mineral found mainly in the hard part of bones where it is stored. The absorption of calcium is influenced by conditions within the lumen of the small intestine. The acid secretion from the stomach converts the calcium to salt, which is absorbed primarily in the duodenum. Calcium also plays an important role in muscle contraction, transmitting messages through the nerves and the release of hormones. If people aren't getting enough calcium in their diet, the body takes calcium from the bones to ensure normal cell function, which can lead to weakened bones. All calcium ingested is not absorbed into the body. The small intestine, which is part of the digestive system just beyond the stomach, is where calcium is taken by the blood and transported to bones and other tissues within the body. There is an unlimited amount of food sources that you can get calcium from, and here's just a very small list of some of the foods that you can get calcium from. One is spinach, kale, okra, collard greens, soybeans, navy beans, all kinds of fish, sardines, salmon as food, and many kinds of breakfast cereals. Here are some really cool facts about calcium. Calcium helps with electricity in nerves and with muscle contraction in the heart. Calcium is the mineral that plays a key role in causing the heart to contract. 99% of the calcium in the body is stored in the bones and teeth. In order for humans to absorb calcium, we need a special vitamin, that is vitamin D. Without the vitamin D, we can drink as much milk or take as many supplements of calcium as we want. Another is, calcium isn't just used for making strong bones. It is used to make cement, cheeses, and removing nonmetals from different metal mixes. Pure calcium is actually a metal and reacts very strongly, sometimes violently explosively, with water and acids. Calcium has been known for thousands of years. The name calcium comes from the Latin word callus, which means lime. The Romans were known to make lime for calcium oxide, brought from mines. The best sources of calcium in the diet are milk, yogurt, and cheeses. Nearly 72% of the calcium in the United States comes from the dairy foods. Even though calcium has been known for thousands of years, it was purified and identified as an element until 1808, and these are just a few of the hundreds of facts there are about calcium, but these are just some cool ones. When you don't get enough calcium, you increase your risk of developing disorders or diseases like osteoporosis, osteopenia, and calcium deficiency disease.